nearly there. Let me finish with a few quotations. I think, no, it's a little bit more. Bear with me, Simon. All of this came about from me reading Leibniz back in 1977 and being very struck by this. This is the means of obtaining as much variety as possible, but with the greatest order possible. That is to say, it is the means of obtaining as much perfection as possible, completion in that. And then he also says, each portion of matter may be conceived as a garden full of plants and as a pond full of fish. But every branch of each plant, every member of each animal, and every drop of their liquid parts is itself likewise a similar garden or pond. Now that sounds rather like fractal self-similar, but this is not what is happening in this case because the structure changes. Now, if you don't increase the number of particles, the number of central configurations seems to come to an end, and then not much more would happen if the number of particles is fixed. But if the number of particles can go on, I don't think there's any end to the different kinds of structure that could be created. So it wouldn't be self-similar, and it could conceivably implement that famous paragraph 67 of the monadology. So the only paper, so Lee Smolin is, Bartlett was a lot responsible for me having such an interest in maximal variety. That's our only joint paper together. But Lee's idea was based on Leibniz's comment, it is as if there were as many different universes, which are, however, but different perspectives of a single universe in accordance with the different points of view of each monad. I think that can be worked into these shapes, what they look like from each point as you look out the angles there. But so from about 2011, having discussions with Alain and Bowie in Paris, I came to think that rather than views that Lee had developed, looking at the shape complexity was the way forward. Nearly there. I think I won't bother about the shape functions. I've already spoken about that. Just the last thing is, well, penultimate, nearly. We're nearly there, patience. So the dominant thing is the law of the instant that determines the probabilities of shape. So as you go out on any of the isocomplexity surfaces, virtually there are very few dull shapes just by this, the way that Boltzmann comes in creatively with the increase of complexity. And then, so then there will be some, so there's two explanations for any shape that you find. So as you wander around an isocomplexity surface, you'll keep on finding interesting shapes. They'll be there. And then you'll find that, lo and behold, there's one of these n-body solutions that Madonna and Venturelli found that comes from alpha, from the most uniform shape, that comes up to that point there. And, well, there are fine-tuning issues there, but I don't want to go into them. Very nearly at the end. Consciousness, solipsism, and Boltzmann brains. So John Bell also said, Everett's replacement of the past by memories is a radical solipsism, extending to the temporal dimension the replacement of everything outside my head by my impressions. Well, I think this offers hope that it isn't solipsistic here, because I talked about that coin, putting it down anywhere in that shape there. So if you put it down and you say, where that coin lands, that's my head. What I've got in my head, in my consciousness, by psychophysical parallelism, is a faithful reflection of what the whole universe is like. And this is completely different from Boltzmann brains, where my brain just fluctuates into existence and thinks it's in this fascinating universe, but really it's sitting in thermal equilibrium. So this is definitely not going to have any problems with Boltzmann brains, and I think it's going to relieve Bell's problems. And I think this is another quotation I found from Maxwell. The only laws of matter are those that our minds must fabricate, and the only laws of mind are fabricated for it by matter. I'm not sure that one can get better than that now. So this is my last slide. So quantum possibilities. First of all, the uncertainty principle caused great dismay because half of the normal degrees of freedom of classical physics seem to disappear. This inverts it, because if the idea with the Madonna-Venturelli solutions is right, give me a shape, just one shape, and I can tell you the whole classical history. It inverts the uncertainty principle, but it's got to be done with the whole universe. So this is about as Machian and Leibnizian as it's get. So there's a kind of complementarity here. So there are two explanations for why we're in the shape we are now. One, and it's the more fundamental one, I believe, it's because fixing the complexity is like finding a is rather like getting a solution to the time-independent Schrödinger equation. So there's an instantaneous explanation of why we are here that doesn't involve time at all. But then lo and behold, there seems to be a classical solution which connects this incredibly rich structure around us down to the most uniform shape that the universe could have. I think most of these solutions, the Italian solutions, will lead to striking time capsules. So finally, this is the really outrageous one, Simon, for you. If this is right, the measurement problem, the collapse of the wave function, is solved. There is no wave function. So I'll finish with that.